Jeff. Okay. Morning, everyone.
Morning.
Let's give everyone a minute and then we'll get started. Okay. Actually, maybe okay, let's get started. I see that Nathaniel is here, which is great news. Nathaniel, can we walk through the HBM example? And
Yeah.
okay. Do you want me to share or
Yeah, you go ahead. I added the active zone
yes. So
install.
okay. I do see the active zone is here, right?
Yeah, I made it the size of the device basically because I think we just determined that for this case we'll just have it be the entire thing.
Yes. So okay, first question. When a rectangle is defined like this, it has dimension 1 and dimension 2. Which one is width, which one is height?
Dimension 1 is in the X direction.
Okay. Is there
So
any reason why these are called like that and not width and height?
that's a Michael question. I'm not sure, but that is just how we do have them defined. And it is defined that dimension 1 is X and dimension 2 is Y.
Okay. Okay. Yeah, that's just a little bit unusual, right? I mean, if it's width and height, it's width and height. It's a little bit clearer, but that's okay. As long as it's defined what it is, I guess it doesn't matter. So this dimension, if I understand it correctly, is actually not necessarily the entire die, but just the bump array, right? This is a little bit too small to be the die, or is it?
Yes, it is the bump array. It is not. It's not the package itself.
Okay. Okay. Now, looking at this dimension, how do I find out of all these terminals what is their what is their coordinate, right? If I take one terminal, how do I calculate its coordinate?
Well, by hand it would be pretty tough, but so there's a DX and a DY.
Okay, yes. So there is you're talking about the pattern that says this is dx dy.
Yes.
It says this many and this is dx dy. Okay. And then is there an entry that tells me, okay, this terminal pattern is placed somewhere?
What do you mean by because I think
So
we have. I mean, so like You see, it says the even row in the column. So that would be where it's placed.
Okay. So what I get from this data here, right, that this has a 12 columns and 110 rows, right?
Correct.
And these are right at 96 pitch horizontal, 55 pitch vertical, right? I get
Right.
that. So if I'm given a terminal that's on column 5 row 55, I can definitely calculate its coordinate relative to the 0, right, to the origin for this terminal pattern.
Yeah,
Right.
because I think so. They should be equal widths and heights apart. So I mean, you should be able to use the row and the column to calculate the exact coordinate of any point relative to 0, 0.
Okay, that's the part I'm not understanding. So if you can help me out on that one, it would be awesome.
Okay.
Walk me through the calculation, how I would go about that. What am I looking for?
So I think they should all. I believe that the DX and the DY is basically two terminals, or yeah, like two terminals apart. So, um, because that's how we did the pattern groups themselves. Like they're basically offset, they're alternating. So I think that the actual difference of every single terminal in the X direction would be half of 96 and half of 55 in the Y direction. So that means if you're trying to go, 3 rows over from 0, 0, then it would be half of 55 times 3. And then if you're trying to go, or well, I guess that would be down. Um, and if you're trying to go, 10 columns over, then it'd be half of 96 times 10. So,
Right. So the way I understand this part is like this, right? I understand the calculation, right? Just the it's raw column times what the corresponding pitch, and that gives me a coordinate that is relative to origin of this terminal pattern, right?
well, yes, but I think that all of the terminals have the same spacing. So that term, the NX, the NY, the DX, the DY for each terminal pattern is
Yes,
set to describe that group. Um,
yes,
but I believe that if we went terminal by terminal, like just through the whole bump map, in the X direction it would be half of 96, and in the Y direction it'd be half of 55. So that's my point, is that every single terminal follows that pattern. So you could use the location. And if Justin, is
okay.
there a way to just incorporate this into the XML? Because if you really wanted to, if we have a way, I could certainly just, put all the locations in there for you. Justin, do you know if that
And,
exists?
so, I mean, yeah, we could put the exact coordinates for every single terminal in there, but obviously that's not a scalable solution, which is why we ended up coming up with this structure a while back for with the terminal pattern and the pattern groups. Um, from a so it's supposed to be a more generates from this
Yes.
the X and Y component, or the coordinates for each ball.
Yeah.
Um, so
I
it's a little bit harder to kind of do it, like he said, like by hand. But effectively, you would take every terminal pattern that has the same pitch and the DX DY. All those you can kind of group together as being like based on a specific pitch, and then after you have those groupings, you can kind of see or go through the various pattern groups to see what kind of transformations are done to make sure that, or to, kind of further the calculations based on what those pattern groups have. So, I
Okay.
mean, it's not
Okay. Okay. Yeah.
easy
Okay. So,
by hand, but
yeah. Yeah. So, uh, okay. So, okay. I think what you said is important. So the pattern group here defines a transformation, right? If I understand it correctly.
Yes.
yeah.
Yeah.
Okay. So what does this tell me? It tells me that I'm taking this pattern ID, I'm taking this pattern, or okay, this is I'm adding the way, okay, so the way I'm getting this is like this. I am taking pattern ID 7 and I'm adding it to pattern ID 8
Mhm.
and I'm giving it these with this offset.
Yeah. So the pattern 98 has that offset from pattern 97.
Okay, okay, and then there's many groupings that would bubble up and this says duplicate.
Yeah, so that one's just duplicating pattern group ID 9 at 3 times in the X direction and just one time in the Y direction with the
And then
that
creating
pitch.
and then giving it with this kind of pitch.
Yeah.
Okay. And all of that, okay, all of that ends up at there must be
So there's that last pattern group that has pattern group ID 22. So that
uh-huh.
contains the 3 pattern groups that consist of all the terminals in their place.
Okay.
You almost kind of have to work backwards from that point.
Yes. Okay. Yeah. Okay. So this is what I was looking to understand. Okay, and that builds up the hierarchy.
Mhm.
Okay, so let me then go back. Um, so this, okay, so if I bubble up all these terminal groups and pattern groups, right, I will get I will get bump locations, right?
Right.
I will get the pad locations.
Mhm.
Okay. My next question then is all these bad names, right? Where I have uh, I'm trying to find where these are. Okay, let me search for one. DQS. Okay, so I have this terminal name, right? This pin pad name. Uh, well, this name.
Mhm.
How do I know where it is in that terminal map?
Yes. So you're looking at the differential pair arrays at the moment,
Yes.
but if
Yes.
you go down, um, there should be a yeah. So oh well, actually, let's see what this is. So this is the function group. So a little bit further down, maybe one more. Yeah. So the terminal map, package terminal map. So Nathaniel, in here the terminal numbers aren't populated, but there would be what the terminal number is for the specific terminal names. And then that would tie into the terminal numbering pattern that's created in the package section.
Okay, what would that look like?
Yeah, so there would basically just be another line in each of those.
Uh-huh.
It would be after ID, but before function ID. I believe it's terminal number, and then that would have like C5, D8, whatever it may actually be. But then that's what ties the package data to the electrical data for the component or for the terminals.
See, now I'm looking, I am quite, could have swore I did that, and now I'm concerned that I might have made the active zone update in an old version.
Um, okay, so this terminal, so with this
Wait,
name
you don't
here,
see the terminal numbers and the terminal map?
terminal number, like this.
I'm
Oh, actually, there are some terminal numbers.
you
Terminal number pattern.
oh, they didn't all get popular. Well, what?
So that's back down in the package section. So those
Yeah, I'm
are
not sure what happened, but it looks like so the first 106 have their terminal number, but after that it doesn't.
Okay, for I guess sorry, my uh uh, did do you hear me by the way?
yeah.
Okay, sorry. So my computer just crashed. Give me 1 second. It needs to reboot. Um, um. Okay, so I can talk. So the overall idea is uh those the terminal map that we're looking at. The terminal number would be the JDX style number A1, B5, and so on, is it?
Yeah.
Okay. So question about that. How does this work if there are two bump patterns with different pitches, right? One is denser, one is bigger pitch. How does that work? How maybe it's a numbering question? How do those get numbered?
So the terminal numbering pattern It I guess it depends on how you set it up, but basically you can apply like a terminal numbering pattern to a terminal pattern group, the whole terminal group, or a specific region. And then like let's say you have the in the HBM example, like the all terminals group, that last one that was in there. Depending on how you define the pattern, which you typically would do it as the grid, and then you would give it the row and column, either as a numerical or alphabetic sequence and then if it's the row left to right or right to left, and then for the column back to front or front to back. And then it would just kind of go through all the terminals as defined in that grid structure and apply the terminal number to it. And so it kind of doesn't care what the pitch is between various groups or terminal patterns or whatnot. But if you do like a lower level pattern group, so something that doesn't include all the terminals, you can add like a prefix or a suffix to that. So let's say you have the left half of all the terminals are one pitch, and then the right half is a completely different pitch. Then you could, if you really wanted to, you could have the pattern group for that left section with a prefix of
Oh
A,
yeah.
and then on the right side a prefix of B, and then they would have two separate numbering patterns with potentially overlapping terminal numbers if there were not that prefix. So I mean, this system, if you will, is pretty flexible. You can kind of do it however you want to do it.
Okay.
Yeah.
So, sorry, give me a second. Okay, I think I should be back in. Okay, sorry. Do you hear me now?
Yes.
Okay. Did you hear my question, or I was
No,
confused?
yeah.
Okay. Okay. What I was saying is that the way I understand this is the physical bump pattern is basically hierarchical, right? There's transformations from one into the other, and things get added and so on,
Mhm.
right?
Yeah.
And from that physical bump pattern, there is the pin numbering, which
Mhm.
basically is a flat pin numbering. And then the all the names, all the pin names are linked to that flat pin numbering.
Yeah, which I mean, it's only flat if you let it be flat. So I mean, it can be a hierarchical pin numbering as well, but for most cases, that's typically not going to happen.
Explain to me the hierarchical pin numbering.
Yeah, so um, let me see if I can share my screen. Okay. So with the way that this is structured, if we take that example of the all terminals pattern group has every single terminal for the HBM within that group. If we assign the terminal numbering pattern to that group, then yeah, it's pretty flat. Or sorry, if we do the pattern group. So if you have, let's say, instead of creating that all terminals group, there's that all terminals group consisted of 3 other pattern groups.
Mhm.
So that would have been, I believe, the top portion or top left portion of the HBM, the bottom left portion, and then the entirety of the right side. So those were the 3 different groups. So what we could have done was created a terminal numbering pattern, one for each of those, that would have a prefix. So we could do TL for the top left, BL for the
Okay.
bottom left, and then the
Yeah.
R for that right side. And then those would all have a A1, A3, so on terminal number, but they would all be prefixed with their respective prefixes. So in that aspect, it's still fairly flat, but it's not uniform, if you will.
Yeah. I get that. Okay. What I was thinking in terms of hierarchical naming is that the lowest level terminal group that you have, right? If you give a name to one of the terminals, anytime you effectively instantiate that terminal group into any of the pattern groups, that terminal name gets carried over, right? In that case, it will be hierarchical,
Yeah.
right?
Yeah. So basically, wherever you specify a terminal pattern or terminal number pattern, any pattern below that, or so anything that anything that makes up that pattern group has that terminal number pattern applied to it. But anything above that, so anything that's using that group isn't affected. So I'm trying to remember the exact example, but let's say you have like every single terminal pattern that's in the HBM. That's probably a poor example, but if you apply a terminal numbering pattern to every single one of those terminal patterns, then whenever you start creating groups, you have to start using the prefixes. Let me pull this up. So you start have to adding prefixes and or a suffix for which for the groups that use those terminal patterns. So pattern 1 and 2 come together to make pattern group 1, and the terminal patterns have their own terminal numbering pattern. Then whenever we create the group, we add a prefix or a suffix to denote that the the prefix would be for the where's that? Yes, I guess you'd add it for the group, and then you'd also add it in here for each of the terminal patterns. And then it will build a hierarchy as you go along, creating more groups and that are using the patterns with their own prefixes. So that way it could be, let me pull up something to draw with. It's hard to describe something like this without visuals. So let's say this contains whatever terminals that make up pattern 1. I have pattern 2, and then pattern 3, and then we create a group out of those 3, and then this is G1. All right, so let's say this had a, okay, that's weird. So the prefix is, we'll just say the prefix is the P1, P2, P3, and then G1. So the terminal numbering pattern that's applied to this pattern has a prefix of P1, and then so on. And then the group, whenever it's created, has a prefix of G1. So whenever this whole structure gets copied, or actually, sorry, let me go in real quick so the terminal numbers for what's in group 1 would be G1, P1, and then this is where the actual terminal number starts coming in.
Mhm.
All right, so then this would continue down for 2,
Yeah.
3, and so on. But then I'll put this in here, and then this would be P2, P2, and then 3, 3, 3. And then let's say we end up duplicating this group. This gets a prefix of G2. So then this becomes G2, G2, G2.
Yeah.
So in this regard, it becomes a hierarchy based on the, I guess, kind of prefixes and suffixes and whatnot. But then let's say we make a group that contains these.
Yeah.
And then this is group 2. Actually, sorry. Say this is group 3. And then
Yeah.
there we go. All right, so then these would still, for the most part, be valid, but I'm gonna take them out to have a singular unifying one. All right, so this would end up being like the G3. I mean, obviously this gets ugly whenever you have not very good have prefixes and whatnot, but then I mean it would still end up like adding another level to that whenever the group is created. Yeah, so that's kind of the hierarchical terminal numbering pattern. At
Okay.
least the way that we have it defined.
Yeah.
And of course, these could have varying levels of pitches between the, well, actually, these ones would be the same, but
Yeah.
but then this could be there, this could be over here, and then we could have another one
Yeah.
or whatever. But yeah,
Yeah.
the terminal number pattern doesn't care about whatever pitch, but yeah.
Yeah. When it comes to pin numbering, what is the use of there was an entry in the XML, if I remember correctly, about missing pins?
Yeah. So that's I don't remember how the XML has it, but there's a couple of ways that it could be done. But whenever you're using terminal numbering patterns, the best way to do it is through the terminal detail exceptions. So if I remember correctly, we may have done it through the terminal details, but we had the terminal pattern ID, and then we listed out the rows and columns that had the missing terminals. So with the various statuses, if it's missing, then the terminal numbering pattern acts like the terminal is there. If it's deleted, then it so this would be the missing is it acts like it's there and numbers the missing place regardless. Deleted is that the numbering continues excluding the terminal that's not there. Excluded, I can't remember exactly what that is, but this would be the
I'm guessing I'm guessing in this case, talking about deleted or excluded, that doesn't really apply when the pin numbering is A1, A2, B1, B2, right? Because
yeah, so let's see if it's missing versus deleted does affect the terminal numbering pattern. So let's say in this case we have the one. All right, so in this case, this is I'm gonna actually just put this in here and color it different.
Yeah.
All right, so this one is either missing or deleted. In this example, it's gonna be missing. So this would be A2, oops, B2, and B2. And then this is,
A3.
yeah, A3. C3 and C3. All right, so this example, it's missing. The missing terminal has the terminal number applied to it, but obviously it's not there and the number is skipped over. It gets a little bit weird with the deleted whenever it comes to like a BGA, because for a BGA to have a deleted terminal, that means that the entirety of the row or column has to be deleted. So in this case, these would be like in
Yeah.
it would be
Yeah. Okay.
blank, and then these would be the A2, B2,
Okay.
and C2.
But is then in that terminal is it applied? Well, no. Let me rephrase my question. Is that flag applied on a single terminal, or on an area, or it could be on multiple columns and rows?
Yeah, so the way that we had done it, we applied the terminal status, I believe, to the terminal patterns, and then anywhere that that pattern is used, so like if it's added into a group and duplicated or in whatever transformation, then that terminal status is still applied to the terminals that are specified. Hopefully that made sense.
Yeah.
Yeah, so let's
So
we go back
okay,
to
so
this and we
it's a flag on the terminal pattern.
yeah, pretty much.
Okay.
Yeah, so
Okay.
then we would just continue on for obviously the numbers are not right, but yeah, so like if that pattern is used again, then those terminals are still deleted or missing.
Yeah.
Which is why I guess it's important to kind of think about how you kind of whenever you're creating the XML, you have to kind of think about how all this should be laid out, which I guess is why it took us so long to get the XMLs
Yeah.
to you.
Yeah. Yeah. Okay. Okay. I think so. Right now, all of this makes sense to me. Okay, going back to the what we were talking before my computer crashed, about the terminal naming that was missing. Okay, can I share?
Mhm.
Okay, so what we were looking for back then is terminal number. Okay, there's the pattern. I don't know why it finds. Okay, so some of these guys did get a terminal number.
Mhm.
Yeah, David, something I have them like filled out. I guess I honestly don't know what could have happened because I did not touch them since we talked about it a while ago. But something happened between when I made an update and sent you this and when they were all populated. But I do have one with them all populated, but I just need to make it correct because it was before we had made some changes to the schema. So there's just
Okay.
some minor errors. But I mean, I do have them all.
Okay. Yeah. Okay. Yeah. Probably that's. When I was looking at this XML, I probably ended up looking at the ones that didn't have it. Got confused. Right. So. Okay, whenever you have the updated file, just send it over. And okay, now I understand how this whole thing comes together. I finally understand it.
This is not a simple one.
It just so you know, I mean, it took a while for me to understand it, and I'm the one that created it. So
yeah, exactly.
Hey,
Okay.
terminal patterns, the pattern groups. Thank you for that, Justin.
You're welcome. One thing I can say about it is it does reduce the size of the XML significantly, especially for billions and billions of bumps.
Yeah. Okay. I'm thinking about some. I'm just trying to make sure I store this information to to the hard drive. Okay. So numbering patterns. Oh yeah. Okay. Last question. So that the top level pattern group. Is there an assumption that it's placed right in the center of the active zone? Meaning that the origin what are the assumptions about the origins, both for the pattern group, active zone, and the alignment of those origins?
Yeah. So if it were not centrally aligned to the active zone, then there would be there's an element that would be under the terminal group array, but after terminal group, called relationship to active zone, and that's where you can define. I don't think it's in that XML.
Okay.
I believe it should be centrally aligned, but there would be a relationship to active zone, and then there you can define uh, in this case, you could do the top level terminal group or pattern group and do a X or Y offset.
Okay.
But if it's
And
centrally aligned, then you don't got to do all that.
okay. Yeah. Okay. So okay. If it's not centrally aligned, and right, I think Michael last time mentioned about writing to the left or to the right and so on. What is the assumption about that alignment? Is it that the center coordinate of the terminal is going to end up exactly on the say if it's aligned left aligned? Is it the assumption that the center of the terminal aligns exactly to that boundary, or is it that the outline, right, the shape outline of all terminals within that pattern group would align to the left, such that the leftmost point of all these shape outlines ends up being at the boundary?
Let me show you the structure.
Okay.
It can handle quite a bit of that. Um, So we're under the relationship to active zone, X offset. So in here, there's various like 27 different point to point definitions. So you have like a left side of active zone to left side of terminal contact area. And then you can specify the distance in there. So if it was the left side of the leftmost terminal is touching the very left side of the active zone, then you could define this as like 0. And then
Yes.
you could have like
Okay.
there's like left side of active zone to center of the left terminal contact area. So that would be like the midpoint of the leftmost terminal. And then the right side of that, same terminal, left side of the center terminal contact area, which so this
Yeah.
is like
Okay.
I mean it's very explicit, I guess.
Yes. 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 Okay.
Yeah.
Uh. Okay. And there's the X prefix that's actually part of the schema, part
Yeah.
of the tag.
Yeah, so
Okay.
there's like a code and then the description basically of what it is. And then there's
Okay.
same deal for the Y, except it's for like the Y equivalent names and whatnot.
Okay.
Yeah.
Out of these, okay, so these terminal definitions, is there anything that tells me which is top side die and which is bottom side die? And which is right, kind of the dead bug view and live bug view?
I don't know what those last two are, but there is the terminal, like for the terminal group, there's the terminal position either being on the bottom or upper of the die, and then within there you can define more position stuff. But yeah, I mean you could, if you have bumps on the top and bottom of it, then you'd have two different terminal groups, one with this being bottom, one of them being upper. And then if you need to define an offset between or for like either one, then you'd be able to specify it separately.
Okay, so here's a confusion that happens all the time. If you talk to a silicon designer, when they look at the GDS and when they do their layout, the active devices are on the bottom, the right, and all the metals then get added on top, and consequently, in a typical flip chip design, a silicon designer would think as the bumps being on top, right? Now, if you talk to a package designer that needs to put the flip chip down, he thinks as of the bumps as being on the bottom, and the top of the die is actually right the other side, right? So that there's this flip in terminology that happens. So basically, what the live bug view and the dead bug view is exactly when you're looking at so live bug view. If you literally imagine live bug, you'd have the bug on top and the legs on the bottom, right? That's a live bug view, and then the dead bug view is when you have all the legs up, right?
Right.
So in PCB design or package design, dead bug view is what corresponds to silicon the designers thinking of topside, right? That now all of this gets a lot trickier when we are talking about front side and backside, right? Especially with backside power and bumps and stuff like that. But the important thing is this bump pattern it needs to be flipped between whoever is designing silicon, or actually it may need to be flipped between whoever is designing the silicon versus whoever is working on the substrate, right? Because they
Yeah.
need to put the bumps down. So how right, this top and bottom and upper it's with reference to what?
Yeah. So this probably isn't the best image to show, but so this is in the JESD 30, the what's little bars in my way, I can't see what the title of it is. Descriptive designation system for electronic device packages and footprints. So this has like kind of like what the as per JEDEC, the standard way of naming these things. So effectively, depending on how it's drawn in like on a data sheet or something, then I was gonna use this one for example. So it's drawn in this manner with the what is it? Yeah, so okay, so the live bug view would be like all these terminals are on the bottom. So obviously live bug.
Hi, Justin.
Hey.
I just joined here. All of these are live bug views.
But yeah. Yeah. So I guess did you hear what David's question was?
A bit of it. So the way we look at it, David, is we don't do any flipping of the component in order to determine what the positions are. We take it as it is. If you flip it afterwards, that's fine. But we never call underside topside just because it's the method by which it is mounted onto the assembly. That comes afterwards. So if you want to take if you take a chiplet and it has bumps on the underside, right, or bumps on the top side, whichever way you want to have it. Let's say it's bumps on the top side, and you flip that in order to do the assembly, then so be it. You flip it on the assembly. But at the time that you define the chiplet, it's not on an assembly. At that point in time, the bumps are on the top side.
I agree.
At the end of the day, David, whatever it is in the drawing that you are issuing as the specification of the part, whatever that drawing says is topside, the JEP 30 says is topside. The JEP 30 does not control the values. It just controls the format of how you store the information. The specification of the part controls the values. So if the specification says this side is top, then JEP 30 is going to implement it as that side being top. JEP 30 doesn't control what the specification is. It just says you put the data into this format.
Yeah, okay.
All right, guys, I need to jump. Thank you.
Yeah, me too. I think I understand your comment, but I need to think slightly about it. I think it makes sense. I just want to make sure there's nothing that we're missing here. Okay.
All right.
Okay.
So sorry I'm late, guys, but is there anything, any message that anybody needs to give to me coming from this?
I don't have anything.
All right. So things are still good, still,
Yep.
okay, all right, excellent. And you got did you get the plan, the floor plan done?
No, I have not completed that yet. We'll do soon. Working on it. There was
Yep.
some unexpected trouble I needed to do, but we'll get it done. Don't worry.
Okay.
All
All right.
Okay, folks. Talk to you next week.
Okay. So Justin, I need to
Nice.
give you a call straight away. And Nathaniel, if you're able to join, that'd be great.
I cannot, Michael. Sorry.
Okay, you're going to, you're going, okay, all right, fine. I just talked to, I'll update Justin. Okay, thanks.